You are tuned to Iri-e-learning, and I am your host, Teacher. For this States of Matter lesson on diffusion, the focus will be on the evidence of diffusion in gases. Check the description box for the links to all the videos for this unit. By the end of this lesson, you should be able to analyze and interpret how diffusion in gases supports the particulate theory of matter and explain why the rate of diffusion varies for different gases. So we're going to do an experiment now, and the aim of the experiment is to observe the rate of diffusion between two gases. The materials we will need include a glass tube 50 centimeters long, 2 rubber bongs, cotton balls, concentrated hydrochloric acid, concentrated aqueous ammonia, retort stand with clamps, and even though not visible in our picture to the left of the screen, we'll need some forceps and droppers. Due to the unavailability of a fume cupboard, this experiment will be demonstrated using the animation that follows. We begin with the experiment procedure. So we have a retort stand, and we see the labels coming up there. And the retort stand is fitted with a suitable clamp which holds a glass tube of 50 centimeters long. And we have 2 cotton balls, one saturated with concentrated aqueous ammonia and the other is saturated with concentrated hydrochloric acid. And these are simultaneously placed at opposite ends of the tube, and then the ends of the tube are then stoppered with rubber bongs. Take note that the cotton swab saturated with concentrated ammonia releases ammonia gas, while the cotton saturated with hydrochloric acid releases hydrogen chloride gas. Next, we will record our observations. Before we do so, here are some questions to guide you in the observation process. 1. What was the color of the ammonia gas and hydrogen chloride gas? 2. What notable change occurred during the experiment? 3. How long did it take before observing the notable change in question 2? 4. What was the distance moved by each gas? Pay keen attention to any changes that occur within the glass tube. The blue background is used to increase the visibility of any changes that will occur. A blue background is suitable since neither of the gases has a blue color. Now, currently, the gases are diffusing through the tube. If you are unable to see the gases moving, then they are colorless. About 3 minutes after the start of the experiment, a white cloud was formed closer to the end of the hydrogen chloride gas source. And specifically for this experiment, the white cloud was formed 9 centimeters away from the hydrogen chloride source and 36 centimeters away from the ammonia source. Here is a sample observation for this experiment. Both the hydrogen chloride and ammonia gases were colorless. However, the ammonia gas had a characteristic pungent or strong odor. At about 3 minutes, a white cloud appeared 9 centimeters away from the hydrogen chloride source and 36 centimeters from the ammonia source. Remember, you should not reproduce these sample documents for any class assignments. The observation is always followed by the analysis and interpretation, which we sometimes call the discussion. Before taking a look at the sample discussion, here are some questions to guide you in your write-up. 1. What evidence is there to indicate that 2 gases diffused through the tube? Explain the significance of this evidence. 2. Write a word and balanced chemical equation for any chemical reactions that occurred in this experiment. 3. Which gas diffused faster? Give reasons for your answer. 4. Explain why the gas named in question 3 diffused faster. So question 1, as we know, asked what evidence is there to indicate that the 2 gases diffused through the tube? Explain the significance of this evidence. Since both gases were colorless, it was just impossible to see them diffusing through the tube. However, when the 2 gases met within the tube, a chemical reaction occurred that produced a white cloud, a precipitate of ammonium chloride. And so as a result, we knew that the gases were moving through the tube in order to have met at some point within the tube. Question 2, we're to write a word equation and a balanced chemical equation for the reaction that took place in the experiment. For the word equation, we know that the reactants were ammonia gas and hydrogen chloride gas. which reacted to produce a white precipitate of ammonium chloride, which was observed as the white cloud. For the balanced chemical equation, we have the chemical formula for ammonia, NH3, state symbol G for gas, the chemical formula for hydrogen chloride, HCl, state symbol G, and the product, ammonium chloride, chemical formula NH4Cl, and state symbol S for the precipitate, because it's a solid. Now, we should always ensure that our equation is balanced. That is, the number of each atom on the left must be equal to its corresponding atom on the right. Note there's one nitrogen on the left and only one nitrogen on the right. There are 3 plus 1 more hydrogen here. That makes a total of 4 hydrogens on the left, and there are 4 hydrogens on the right. There's only 1 chlorine on the left and 1 chlorine on the right. So as a result, this equation is balanced and good for use. Question 3 asked which gas diffused faster and to give a reason for the answer. The ammonia gas diffused faster than the hydrogen chloride, and this was evident because the ammonia moved a greater distance through the tube. It moved 36 centimeters, while the hydrogen chloride moved only 9 centimeters, because the white cloud is formed where the two gases met. And question 4 asks us to explain why the gas named in 3 diffused faster. Ammonia diffuses faster than hydrogen chloride because the ammonia particles are much lighter than the hydrogen chloride. In other words, the ammonia particles have a smaller mass than the hydrogen chloride particles. How do we know this? We calculate the mass of the particles. If we take a look at the periodic table, we will notice that for each symbol of the elements that appear on the periodic table, there are 2 numbers associated with it. The larger of the 2 numbers is called the atomic mass, and it is the number we will use to calculate the masses of the particles. Now, a particle of ammonia consists of 1 nitrogen and 3 hydrogen atoms. You may notice that the atomic mass of nitrogen is 14 and that of hydrogen is 1. Therefore, the mass of an ammonium particle is 17 grams, and we arrive at this because the mass of nitrogen is 14 grams and the mass of each hydrogen is 1 gram, and there are 3 hydrogens, so we add the 1 3 times, we get a total of 17. We can peep at the periodic table once again, this time for hydrogen chloride, and as we saw before, the atomic mass for hydrogen is 1, and that now for chlorine is 35.5. And based on the atomic masses of hydrogen and chlorine, we get a total mass of 36.5 grams. As we saw, there's 1 hydrogen which has a mass of 1 and 1 chlorine which has a mass of 35.5, and that gives a total of 36.5. And based on our calculations, the ammonia particle is much lighter with a mass of 17 grams compared to a much greater mass for hydrogen chloride of 36.5 grams. As a result, the ammonia particles will move much faster. Here is the sample discussion. The movement of the ammonia and the hydrogen chloride gas was not visible since both gases were colorless. However, a chemical reaction occurred where the 2 gases met within the tube, which produced the visible white cloud. Since the white cloud was formed away from both gas sources, this proved the gases moved or diffused through the glass tube. The word and chemical equations below outline the chemical reaction that occurred between the 2 gases. Word equation: ammonia gas plus hydrogen chloride gas produce ammonium chloride solid. The balanced chemical equation: NH3 gas plus HCl gas produce NH4Cl solid. Therefore, the white cloud observed was the white precipitate of ammonium chloride, NH4Cl. The data proved that the ammonia gas diffused faster than the hydrogen chloride gas because the ammonia moved a greater distance of 36 centimeters through the tube, while the hydrogen chloride only moved 9 centimeters. Therefore, the ammonia gas diffused approximately 4 times faster than the hydrogen chloride gas, which explains why the gases met at a point further away from the ammonia source. The notable difference in the diffusion rate of the 2 gases was directly related to the difference in the masses. The mass of ammonia was 17 grams and hydrogen chloride 36.5 grams. Consequently, the air particles pushed the lighter ammonia particles further through the tube within the 3 minutes. Be reminded that you must not reproduce this sample document for any class assignment. The lesson summary points include particles with smaller masses will diffuse faster than particles with larger masses. Ammonia diffuses faster than hydrogen chloride. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.